Everyone, I'm Ken Rakowski, and I'm your host and your chairperson for the Blue Area, where we'll bring on different people around autonomous technology, AI, and just next level thinking. I want to introduce you to Dezso. Dezso is, I would say, if you want to look at the word cool in the dictionary, his picture is next to it, because he personifies the word cool. He's worked on tons of projects, from the Blue Origin with Jeff Bezos, to some of the most amazing projects that are out there, X Prize. His current project, that he's a passion project for how many years? A decade? More than that.
18 years now, yeah.
Put the microphone close.
18.
18 years is all around taking what normally would be on the ground and bringing it to a flying aspect. He's going to give us a presentation. I'm very eager to learn more. Let's give it up for Dezso, everyone.
Thank you, Ken. So, very quickly, I'm just going to tell us about what is technologically viable about this. I'm not going to mention racing as a business so much, although I'll just say quickly, look, Formula One cars are €500 million a year to fund them. Bernie Ecclestone's daughter lives in the biggest house in LA, so there's businesses there, but I'm just going to focus on the fun stuff. I'm going to need my little clicker here. Thank you, Your Honor. Grazie. So, the flying car world is a little bit just confused as far as what it really is. I'll just say that a lot of development's been done recently with jetpacks. People want jetpacks in the future. We have them now, but most people don't want them. What we're finding is I've got friends, David Mayman, etc., we found they're very challenging to fly, and they're amazing for what they do. They're really incredible, but they also burn a gallon of fuel a minute, and it's not the kind of thing that we're going to all find valuable for ourselves. And so, like I said, a lot of development done, but I don't perceive jetpacks as being flying cars. I'm in the flying car world. Quadcopters, as you can see here, there's a lot of consumer versions of these available, and people looked at them and said, well, can't we just make them bigger and sit inside? Well, a lot of money's gone into that, and it's true to some degree, but it's right at the limits of what people can do with the motor technology and the power sources that you can carry with them. One of the challenges have been for people is that, again, power density. The one that you see on the bottom here is done by my friend Ivo Zdarsky. He just used weed eater engines and some gasoline, and these things run great. He's been running these for 20 years. And that's because you can use a gasoline engine to spin a propeller. You don't need to have them total control over that propeller. So a lot of development's been done with stepper motors and things like that to run those. But what I've found is that it's a much better application to use those electric motors to drive a wheel, because you can go from 0 to high RPMs with no challenges of transmission. A lot of what's new today has actually been old. So what you see there is the Hiller flying platform. I actually got to meet that pilot. He was about 90 years old when I met him, but I used to work with the chief scientist at Hiller Aviation. You see the Williams Wasp, the Augusta Westland in the middle, which runs with a massive cable because there's nothing to power it. Paul Moeller's flying machine, which doesn't fly. I used to watch that for years. The Sikorsky Air Jeep. A lot of these things are being recycled. Development's coming from small groups. Boeing doesn't really have too many ideas, so what they did years ago was they showed, I think it's probably a little helicopter they got at the toy store, and they put a shape around it, and they put it next to a car in the Smithsonian to make it look big. So what they've done since then is there's some, you see the we see the Aerocar. These are helicopters from back in the 50s, and some gyroplane approaches. So what Boeing has done is they've sponsored a prize. So they've given a very challenging set of requirements for people to perform with their vehicles that they've designed in pursuit of a $1 million prize. So we have a $1 trillion company providing $1 million for people to solve some very challenging problems. So no one's been able to actually fly this challenging course yet, and it is daunting. I assure you, it's daunting, and these people are very brave for trying. They had a Go Fly Prize event in March at the NASA Ames Research Center at Moffett Airfield earlier this year, right before the COVID lockdown. And so there was some amazing developments and an amazing amount of soul that goes into these machines. But again, Boeing is a defense company, and there's a new operation called Agility Prime, which is a defense contracting part of the military, where they're purchasing. The idea is to purchasing consumer products to use for defense purposes. So that's a long way of saying we're asking you to develop these weapons for us at a very low cost so we can buy them. There's a lot of these machines being built right now, a lot of them in development stage, both in drawings and in fabrication. One of the more popular ones we saw was Google. Larry Page has spent an enormous amount of money developing vertical takeoff machines. There's a certain addiction to vertical takeoff. This machine on top has been discontinued, the Flyer. This one here is from Tu Young, and that's is a Toyota machine on the lower right. Again, there's a lot of obsession with taking off vertically in a lot of these developments. It's a very daunting task. The Flyer program has been canceled. They're probably 100 million or more into that project to find out that it effectively didn't work, and it's been canceled. The statement there that you saw from Sebastian Thrun on the last one, what some people call flying cars, which I do, they have wheels. And I do think that flying cars have wheels, and it provides an extremely important value, which is if the weather's bad, you can still travel. And also for racing, if the weather's bad, you can still race. Nobody says, weather permitting, we can't do this today, which is what happens with space shuttles and things like that. So the other said their claim is that they want to solve the world from traffic. I think that may not be the case, because when you create systems that allow you to have traffic, that allow you to commute from London to Glasgow, then what you do is you start creating congestion, because you've now exceeded human endurance and you're enabling people to get in line to wait to get somewhere. So I would just say that I personally have no interest in solving traffic problems. I have an interest in avoiding them or flying over them, or in some cases such as Hurricane Rita, which you see photographed here was the exit. People were able to drive through that with their motorcycles in split lanes. There were 120 people died in that commute from Dallas to Dallas from Houston, and that's a very daunting situation as well. So we like to avoid traffic if we can. What has rolled out of Google's project, Larry Page's project at Kitty Hawk, is the Cora aircraft. My friend Dave used to fly this one. They've teamed up with Boeing again, and the one you see on the bottom right, which I think is actually here, is a mock-up of Joe Ben Bivert's machine, and it was an Uber development with Mark Moore from NASA. Again, these are vertical takeoff machines. The ambitions of these machines is to certify them effectively so that you can purchase a ride. And so their ambition is to have a person hand them money, give them a ride, and then give someone else a ride in exchange for money. So it's a cash transfer machine. The idea is to make a person who wants to be somewhere else pay to get somewhere else. So I take a different approach to that. It's much more about self-preservation. Here we see Joe Ben Bivert. He's here. This lovely man. He's a brilliant guy. He invented this little gorilla pod for holding on to cameras, and he sold those and made a small fortune, and he started investing it in his vertical takeoff machine developments. He used to work with Paul Moeller in Davis back in the day, and he realized that electric motors might help with that. Same situation. He's working for certification. He has an extremely large and talented group of people there, but what they're doing is they're developing a machine that will allow them to sell rides. And that's something that used to happen here with New York Airlines, where, again, we have a certified aircraft that's able to take off and land, but it crashed on the roof of the Pan Am building in the 1970s. So it's been about 40 plus years that this has not been done again. So one of the challenges these people face is that when they do develop these machines and they're able to fly them safely, and they're doing it in a way to be cost effective and make money, that as happened with this one they allowed this slip on some of the maintenance, and they ended up killing a lot of people, and they have not been doing a lot of flying since. So what another sidestep of this is they're developing specific airports for these machines. They're calling them vertiports. The one you see here the concept is that they need a specific airport for their vertical takeoff machines, but they've located it very conveniently right next to the Orlando International Airport. So the fact that they need a separate airport by the airport for a machine that doesn't require an airport is a little confusing to me, but they haven't told me where they're going. So once I find out where they're going, maybe it will all make sense. But I will also point out that this number is actually incorrect. There's 20,000 airports in the United States, and there's about another 15,000 around the world. So we have a lot of airports, and most of them are unused. Again, 20,000 airports. There's less than 1 million airplanes in the world. 20,000 airliners. Most of the airports sit idle. Most of the airports, the aircraft that are there, again, there's less than 1 million airplanes in the world. We've got about 350,000 in the United States. Most of them never go anywhere. They just sit there because people can't afford the gas. So what I started doing was I said, well, there's a lot of engines out there and motorcycles, and they're overpowered. You can buy a motorcycle with your mom's credit card and drive yourself into a wall faster than you can jump off the mountain and into a cliff. You can literally smash yourself into a wall at 200 miles an hour. There's so much power. You don't need it, though. So what I wanted to do was tap into it in a way that would let me fly. So what we did here was I made a motorcycle that was a bit stretched out, and this allows me to both drive and fly. This one, I'm happy to say, we built this one 15 years ago. We had our first flight this week. It was 15 years ago. And I'm happy to say that the Smithsonian Institute is accepting, they're going to put photos of this into a new exhibit in 2022. So this is my first aircraft, and it's made it in the Smithsonian. And what it did was it illustrated that we could use an off-the-shelf motorcycle engine, which has a license to drive on the street. One of the challenging things that you have to do with a motorcycle or any vehicle is you have to pass smog restrictions. So once you have selected an engine that can pass smog, then you can build a machine that you can both fly and drive. There are no smog restrictions for flying. You can have a very dirty jet engine and fly that. So this is the first machine we built, and the second one was I started developing a two-seat version of it. And this one, we have the ergonomics where the person sits one in front of the other, and that keeps the machine very narrow. So that reduces the amount of drag that you create, and it makes it, again, much more efficient, both on the ground and in the air. This one is able to lean side to side. It's very fast. It's probably the safest street bike, I think, in the world, and it's probably the best one, I'm willing to say, because it's very quick. You never pull a wheelie. You have a lot of steering control with the front wheels, and I won an innovation award for it a few years ago at Quail Lodge. And so carrying it forward, I installed a propeller, and this would also allow you to fly just the same as the first one. Similarly, when I started this project was in 2003. Since then, just in recent weeks actually, PAL-V, they've been working on in parallel a two-seat version of their machine, which is very similar. It's also a gyroplane. It uses rotor blades to fly, and it has propeller that drives it forward through the air. Very safe system that allows you to land if you have a power failure, whereas, again, the quadcopters that are so popular, those have no safety systems if they have a complete power failure. So this one will allow you to gently land, and that's actually how they always land. You simply pull the power, and you fly in, and you can land the machine. Due to marketing challenges, I think, or I should just say marketing pressures, they've seated the passengers side by side, which makes this vehicle wide. And I think they might have done that because there's not a lot of people who can fly these machines in the world. There's only 4,000 pilots in the United States with a license to fly a gyroplane. I'm one of them. And I think most of them probably have that license just as a fetish in order to say they have all the licenses. I don't know that there's really 4,000 gyroplane pilots in the U.S., but they as far as activity. Anyway, this is a rare machine as far as having the capability to fly them, but I'm all for people learning to fly. I think it's a very important skill, and no one ever said, well, we're going to build a Ferrari, but you don't need to learn to drive. People need to step up and they need to learn to fly. It's a very beneficial thing to be able to do. As, you know, we just had a discussion about trains, but the reality is that I've been saying this for years, it's a very good thing to be able to rely on yourself and your own machines and your own abilities to get around when the time is necessary. So the PAL-V machine is a €500,000 if you want one. This is a very similar machine here on the lower right, the Clever and the Carver. That was actually the foundation of the PAL-V machine, was a failed car company, Vandenbrink Brothers and Carver, in the Netherlands. So they use that as a foundation because it's a great machine with tandem seating for driving. And that's on the lower right. That is called the Carver car. Excuse me, this is the Clever. The other one was a Carver. I can't remember. Very similar. This one built by Bath University and some students in Germany. I think I saw this one in Berlin. But I did a lot of study when I set this up by determining what the ergonomics were between these different machines. And so these are very comfortable. And then my friend Richard Hatfield, the one on the top. Now, that's an important machine. It's his cabin car. It requires 2 horsepower to drive at freeway speeds, okay? Because it's so aerodynamically clean, 2 horsepower. When people are talking about, well, we're running out of fuel, we have energy problems, a lot of what people do with these machines is all they do is they push air. This picture you see on the upper left is about streamlining, okay? I had a woman working with me a few years ago. She was a graduate, a master's degree graduate in engineering. I asked her, why do cars have engines? And she couldn't answer the question. And finally, after a while, she said it helps them get up mountains. I said, that's correct. But most people aren't climbing mountains. Mostly what it does is they push through air. So I would say when people are talking about global warming, power challenges, etc., what we're doing with all of our energy is we're shoving air out of the way. When people talk about vehicles, they talk about range. It means how many millions of tons of air are you going to shove out of the way? The answer here is that it's very, very valuable to start streamlining things so that as we move through the future, as there's more and more people, we spend less energy shoving air out of the way. What you see here on the left is a 2% efficient locomotive, steam-powered. Okay, so 99, you put in 100% of the coal, 2% of that power comes down to the wheels. Most of it goes out as heat. On the right, we saw the Burlington Zephyr, and this was in 1933, I believe. This was at the World's Fair. And that machine was able, with diesel engine, to go about a little over 100 miles an hour, 110 miles an hour. So the one on the right has 550 horsepower. That carries 120 people at over 100 miles an hour. The one on the left carries a very large Ego with 808 horsepower. Now, that person isn't helping anybody. This troglodyte machine, they've been shoving these things down our throats for 60 years. We're coming out with the new Ford Bronco. In the middle, you see the Yukon, which I think they named after all the animals that they're killing in the Yukon with the front end. I'm a big advocate. Like, nobody talks about streamlining. They don't talk about roadkill. There's a road in Brazil where they're logging, there's 1 billion animals, billion creatures killed per year on this road. If you make your machine smaller, more streamlined, and lighter, the one on the bottom right that I'm building is about 700 pounds as opposed to 7,000 in the middle, then you're looking at something safer. I'll back up really quick. You'll see that they did care about cows with the black train there. They cared enough to put a cow catcher in the front to protect the people in it and the cows themselves. The one on the right, they were very concerned. The drivers didn't have anything to keep them from getting hurt when they ran into cars and stuff that were stuck on the track. In the future, we'll have trains that can stop, but not today. Anyways, next thing forward. So Dean Cain is a brilliant engineer and inventor in the United States. He has an organization called First Robotics. His ambition is to get kids to build robots so that they learn a lot about the skills about making these machines. And he has a great quote, which is, it's the one sport that every kid can do where they can turn pro. And I love that part of it. And so you can see the kids get very excited about it. They make these machines that you don't really want to own at the end of the day. They're very clunky looking, and they do very specific tasks for whatever the ambition is that year. There is no second, okay? So the First Robotics is a thing for high school kids. They have 14% penetration through the high schools in the world. Every year they have a world conference final that takes place in a massive football stadium. Fits 80 or 100,000 people because there's so many competitors. It's a great thing, but there is no second. And I asked Dean, I said, well, what's going to happen? Are you going to do a university level version of this? And he said, no, his ambition is simply to have more high schools competing in this. So that's what you have there. If you have the second, I mean, right now the closest thing we have is drone racing probably, which is a very technical thing. Guys get involved. They wear these headsets that are extremely good for visuals and control of the drones, and they're also very effective birth control devices. And it's not something that everybody wants to do, but I would say that if you're a college kid, you should be doing what they're doing in Brazil. So this is Anakim, which was built in São Paulo University. They built this airplane to break speed records, and that's exactly what it did. They fit themselves in a class for 4-cylinder aircraft. The students designed with CAD programs and hand-built the machines. Very, very good infrastructure for aviation in Brazil. They work very closely with the university and Embraer, which is a crown jewel development group there. At the bottom left, I was working on the 2-seater I showed you with Mr. Marcos Pontes, now Dr. Marcos Pontes. At the time, he was a cosmonaut, and now he's the head of all science and technology for the nation of Brazil. And I just put it out there since we're in Dubai. I would suggest that if anybody wants to start having a flying car races with Brazil, I will tweak Marcos and say, look, I think they need to start racing Dubai in this class. So he was here actually in Masdar City in Abu Dhabi, helping do some development there for ecosystems. But this is what I think we need to have coming out of the university level. Since kids build robots that nobody wants, when they graduate in high school, it's time to start making aircraft that you want to keep for the rest of your life. This slide is simply about the idea that we have an extinction scheduled right now. So for the investment that we've been making since we've started burning oil at massive amounts, we are looking at a lot of problems as far as evacuations, storms. The world really wants to cool itself down right now. And so all birds are dinosaurs. They survived the extinction. I don't know if they were, maybe they hid some eggs in the ice. Maybe they were flying. We don't know. But there are no birds that were not around previously. The one you see on the top, that's recently found a fossil for that. 138 million years, that bird hasn't changed. Well, these are the birds we build. And I tell people there's only two ways to make vehicles lighter. You have to either pedal them or you have to fly them, okay? So here you see an aircraft. It's basically, these things are about $400 a pound. Let's say that, a kilo. And the idea is that the mechanisms and the tools and the activities that you do to build an aircraft are fairly labor intensive. And the nice thing is these machines are also quite modular. You can put them together and take them apart. Bicycles the same. They're now using carbon fiber. They've been racing them since the 90s. Now, the average car is worth about the same as cheese. It's just a piece of junk. It's a chunk of crap lead. And that's for a new one. If you buy a used one, it's even worse. Okay, it's nothing applicable to the largest industry in the world, which is the automotive industry. Nothing is applicable to the streamliner world. None of it's applicable to the racing world. It's all heavy junk. Therein lies the gap. There's a reason why you can't apply this stuff, and therein lies a business opportunity to make that stuff work. So the car on the left I built 20 years ago was designed to go past the sound barrier. We didn't run it to the sound barrier. We got close, around 700. It's in a museum right now and rotting away. And on the right, you can see I built some rocket-powered airplanes to race. I think that was Bridenstine's. He's now the head of NASA. But these machines were very expensive to run for racing. It was $50,000 every time we took the car out and ran it for 90 seconds. The airplane, same thing, $12,000 a minute. Very, very expensive. Race cars are very valuable. If you do race them, like those machines you have, they have a racing history. That's the difference between a cheap Ferrari and an expensive Ferrari. The plane I show you on the right, that one's 80 years old. People are still flying it. I just took that photo about 3 days ago. So people use these old aircraft over and over because there's no replacements for them. Now we have electric motorcycles that are very robust. My friend builds the one on the top on the right, 220 miles an hour off the showroom floor. These engines, or these motors, are very applicable to aircraft. We're just starting to use them. What I did was, the process was I have this airplane on the top left. That's mine. I bought it for $6,000. They're super cheap. Airplanes, you can get them. You can make them by yourself, hand built. I used the electric motor from a motorcycle. I envisioned this little shape on the bottom left as being a very streamlined system to make a flying car that I can drive and fly. And I wanted it to be as simple as a soapbox derby racer. So this is what we've come up with. This is what I call the street wing. The idea here is that this is a plug. This is the shape that we're going to use. We're going to make a very structural shape, a structural composite vehicle from this shape. And I'm going to start road testing it in 2 weeks. So I'll leave here. We're going to put a license plate on it. We're going to start driving it around in California and start road testing it and getting a feel for how it behaves. It's going to have a propeller on the back to push it, and it has a powered rear wheel. So the plan is we have wings that we simply plug in and out. So it allows us to do rapid development. If I don't like the wings, I make longer ones. I make different ones. And again, it's a legacy aircraft design. And then you simply plug them away, and you can drive down the street. And because it's a racing machine, I'm looking at about 200 miles an hour on the ground, which is fast enough. And in the air, about 250 or 300 in the air. On the bottom right, one of the things we'll do is we'll put solar panels on the wings. So we can get 1,800 watts off of 7 square meters. We'll get some amount of speed out of that, non-zero. I don't know if it's going to be 10, 20, or 30, but there are regularly solar-powered races where these cars are getting up to 80 miles per hour with 5 square meters of solar panel. So what I'm doing is I'm starting a flying car racing league. There's 100 good flying cars in the world already. The PAL Vs that I showed you earlier, there's 110 of those that are on order right now. So people are going to start populating this space. There's never been a flying car race. That's why we don't have them. People, they compete with tennis rackets, Speedos, bicycles, everything. That's why people have quality equipment in those realms. Because there's never been a flying car race is the reason you don't have a flying car. So anyway, that's what I'm doing. Also, I'll just say quickly, I'm doing a story right now with Alta Magazine that will be coming out in Q1. And also, we're going to show the machine I just showed you in at the LA Auto Show. It'll be there for 12 days in May. And that's what I have. So thank you for my that. And then, Ken, if you have any questions. All right. Testing.
Dezso, there
Yes.
he is. So Dezso, the cost to do these things.
Yeah.
What's it cost to actually create what you're making right now on the red one, whatever that one was? What do you call the red, the image that you showed us?
The new silver machine.
What's it cost?
Well, I've self-funded myself through the development, and it was affordable, I'll just say. But basically, the next step of having one flying is it's less than $1 million.
And that $1 million prototype will lead to what?
Well, we'll be able to test it and find out if it's completely a viable shape, and we'll be able to alter it in a lot of ways. And at that point, have something that we can use constantly and do continuous development and upgrades.
And then once something like that's implemented, where people can actually see this,
yes,
it wouldn't be a kit. It would be something beyond a kit, or we're looking at something commercially available.
It could be. The trap has always been certification. Most airplanes that are built and flown, all you need to do is fill out 3 sheets of paper. And as an experimental aircraft, that's it. It's a lot easier to get an airplane in the air and fly over a city than it is to put a motorcycle on the road. It's virtually impossible to put a car on the road. It's extremely easy. And the challenge has been people get sucked in by the idea of selling turnkey machines to people. And then you see as the red one, where they suddenly said, well, the market demands that we now have 2 seats next to each other because the people who are going to fly it don't have the qualifications to fly it. So you're designing for the lowest possible denominator of skill. What I want to do is, by positioning in racing, I'm positioning in a place where the people are skilled, they are able to develop it, and we completely avoid the entrapment of creating consumer for products for consumers that do not exist.
You were excited about coming to Dubai.
Yes.
Because you feel that they're very open-minded.
Oh yeah, they're the best place in the world. Definitely, they've been very quick to, with the Dubai Human Flight Project, with Yves Rossi, and with jetpacks. They were running hydrogen peroxide jetpacks. It's a great place, I think, for, again, the desire for innovation, and clearly for the application of innovation here. There's a lot of wide open space and a lot of reasons to travel through it.
So they should really find a way to embrace what you're doing.
Well, I won't say what they should do, but I hope they do, and I think it would be, again, I think it's a good fit.
So Dezso, if people want to find you, hunt you down, where do they go?
They would go to Flying Car Racing. That's Flying Car Racing is my website, and that's the sport. It's a new motorsport that we're starting, and we will not be anonymous from it. A lot of what I showed today was the first time to see it, and so you'll see a lot of it in the future. I'm going to run a quick video here. This is just as simple as it gets. This is where I do a lot of my flight testing. So the idea is, if you have a flying car race, you want everyone to be safe, and I want to be very inclusive. So I've made a setup where any person that builds a flying car, it's very easy to do, and I'll help walk you through it if you want it, if you don't have one already. A lot of enough people do. What you're seeing is just me running a gyroplane around a nice big open desert area. And it's a 10-mile loop, and this will allow you to fly and land if you need to, if you have any problems, land if you need fuel, etc. So there's no range requirements. There's also no piloting requirements. A person doesn't have to be a pilot. There's no altitude requirements. What we do is we are going to run around this track, and we'll do a couple of laps. Again, with the existing infrastructure of these aircraft that already exist. There's hundreds of them. And then once you've finished doing the flying part, we'll land on the ground, and you're going to drive down public roads for about 100 miles, 200 miles. So the machines have to be able to fly, and they have to be able to drive. And it's valuable for this reason. Most people die in their airplanes because they fly in bad weather. Okay? Even some of the best pilots ever.
Does the gyrocopter, does it fold out?
This one is just one of my aircraft I have out there just to demonstrate it. Yeah. This one only flies. This is not a driver. And it's just to illustrate the course. The one I showed you earlier, I can fly that and drive it. But again, it's now a Smithsonian exhibit, so I'm very slow to just trash it every day. You know, I'm trying to think forward a little bit. But the idea is just that, I think I go back to that one. So the idea was just to demonstrate that the course is not daunting, okay? I don't want people to think that we have to fly from city to city. Eventually, that's the plan. I want it to be like the Tour de France, where this is something that goes from town to town to start driving the development and driving the requirements of the vehicles.
That's awesome. Anyway. Everyone give it up for Dezso. Thank you so much, Dezso.
Thank
I
you so much.
appreciate it. When we come back, we're going to bring Nokia up and find out where Nokia is working in autonomous vehicles. So thank you very much,
Thank you,
Dezso.
Ken. Appreciate it.
Hey, Sammy's trying to get a hold of you. If you don't mind, do you have your phone on you? Yeah, my producer.
Oh, okay.
For metal.
Yeah, I have.
Here.
I have my.
She wants to know.